This right here is one of the biggest projects I've ever made. Hi! In today's video, I'm going to show you how to make this awesome project. This project, as a disclaimer, is very difficult and tedious. And if you don't like projects like that, please do not attempt trying this. This took me 3 days and 16 plus hours of work for me to get it to this shape. When it works though, it's just the feeling of the accomplishment of making a project that is quite hard to make, and then it functions. It's just a great feeling. And of course, this is a 4x4x4 LED cube. And today I'm going to show you how to make this. So the needed parts for this project are not that much. When you don't include the LEDs, there are not much parts on this project. You need 64 LEDs, some wires, a battery or a power source. In this case I used an 18650 lithium-ion battery plugged into a battery holder right here, as you can see. Let me actually open this up. As you can see, the bottom of the circuit is held on with the Velcro on top of the battery holder, as you can see. And there is the Arduino Uno, as you can see right here. And there's also a switch, a TP4056, and hiding behind the battery holder there is an MT3608, which makes the voltage go from 3.7 volts or 4.2 volts up to 5 volts. You can supply the 5 volts or higher voltages on the voltage in pin of the Arduino, which is what I did. The voltage in pin is good for regulating the voltage output from a voltage regulator or a battery source. So the MT3608 isn't known for its best noiseless voltage output, and when I tried to hook it up to the 5-volt rail, the project would just completely not work. The LEDs just would light up randomly and the functions just wouldn't work. But when I plugged it into the voltage input, it worked perfectly. There is the TP4056 for the charging of the battery and the battery protection right here, and the output pin is going directly to the switch, and from the switch it goes into the MT3608, and the MT3608 is directly connected to a JST connector, goes onto the Arduino's voltage in pin, and then there's the connections for the LED cube right here, as you can see on the bottom. This cable mess doesn't look all that good, but this is the shortest length of cables that I can have for this project. Otherwise, if I make these longer, it's just gonna become even more ugly, and if I try to make them shorter, some of the connections just wouldn't reach, and I would probably end up snapping some connections. So I went with standard jumper wire length, which is around 10 centimeters, I think. And there is 20 of these wires connected to a perf board on the Arduino, and the perf board has all the digital pins and the analog pins outputted out, as you can see, like this. It's basically like a shield for the Arduino Uno. By the way, you can also use the Arduino Nano. In fact, the Arduino Nano has 2 more analog pins than the Arduino Uno. The Arduino Uno has 6 analog pins, but the Arduino Nano has extra 2 more, so it has 8 analog pins from A0 to A7, but the Arduino Uno has analog pins from A0 to A5, which makes 6 analog pins if you count the A0. With those 2 extra pins, you can add a button or a buzzer, or both. So that way you can control the settings of the project if you code it in, and you can also make the buzzer make noises when it's switching between modes, or make it compatible with a music rhythm or so. But in this code I don't have any of those, and I don't want to mess around with the code because I did not write the code. I just pulled it from a different source. This project is actually inspired from a website or a blog that is Kyle the Creator, I think, who wrote this blog. Let me check. I'm gonna show it to you in a minute. Yep, Kyle the Creator, and the blog is in Autodesk Instructables. So I just looked up the instructions on that blog and made my own LED cube. So how the wiring of this works is, like, how do we control 64 different LEDs individually with only 20 outputs on the Arduino? By the way, the analog outputs are not only an input, they can also output voltages. They can output high or low, the analog pins on the Arduino. I thought that the analog pins was only good for inputs, but actually it can also output voltage. So this is very handy for this project, because there is a multiplexing technique on this project that we're using. As you can see, the cube has 4 layers of different LEDs right here. 1 layer, 2 layers, 3 layer, and 4 layer. And each layer has 16 LEDs in them. So if you multiply 16 by 4, there is 64 LEDs. And the layers are only 4 pins outputted. The columns of LEDs in each layer is completely connected to plus. Like, there is 16 LEDs on each. Let me just turn this off to make it look better on the camera. So there is 16 LEDs on each layer. If we're looking at layer 4 right now, every LED's positive is connected to the other LED's positives. So this is a positive pin of 16 LEDs, and the negative connection of the LEDs go down to the 3rd layer right here, as you can see, and connects to the 3rd layer's LEDs individually, and then it goes down to layer 2, goes down and connects to each individual LED, and the same happens when we go down to layer 4. So we have 16 individual LED connections, that is from the LED's ground connections on all of them, and they're all connected in between those 4 layers, if that makes any sense. And all the layers, individual layers, have a positive connection on them. So we can just, if we want to light up this LED, for example, I'm showing it, pointing at it with my finger, and if we want to control that LED, we're just going to send the layer 1, which this layer is layer 1, the positive signal, and then on that probe right here on this pin, we're going to send negative voltage, and this LED is going to light up. Or, for example, we want to just turn on this LED, we can go to layer 3, energize layer 3 with positive voltage, and give this column negative voltage, so that that LED lights up. And if we're giving this column voltage, negative voltage right here, as you can see, and if while this layer 3 LED on this column is lighting up, if we give other layers voltage too, like plus voltage, all the LEDs on this cube is going to light up on this column right here, this column. So this is a very basic multiplexing technique that allows us to control 64 LEDs with only 20 pins, which is quite a good achievement. If we look at the template, which I have printed out from Kyle the Creator's blog, right here, it's a PDF file and I printed it out, 2 of them to be exact. I used this one, wrapped it around this template, this wooden board, wrapped it around there, marked it with a marker. Let me show the marker I used. Marked it with a permanent marker, and I just drilled the marked points with a 5mm drill, wooden drill, or a metal drill could work too. I drilled on wood because I tried to make it on a cardboard box, but the cardboard box was small, very small, so the LEDs wouldn't fit. I tried it on a bigger box, it was a little bit thin, and the LEDs just wouldn't stay on the holes. So it was quite problematic to do it on a cardboard box. If you can do it on a cardboard box, you can do it. The original piece was a lot larger, and I drilled it through, like drilled a lot of holes around it, and basically cut it through with my drill, because I don't have like a saw or anything, so I needed to get this piece off with my drill, because if I only had the large piece and drilled it through that, it would be really hard to work on. I had to like put it on the desk, and it would be like not good. And this one is much more compact and easy to work on, this template. And if I want to make another one of these, I can just use this template again, because it's just not gonna get damaged or old or like worn out. It's just wood, so it's very durable. And if you try to make it out of cardboard, you would probably have the issues like I had, the LED just dropping to the other side because the hole is a little too large, or the LED not sitting properly. But I just drilled 5mm holes in this, and the drill bit was, I think, a little bit smaller than 5mm, so the LEDs would fit like just tight enough to stay there and like not move, so that I can solder them properly, which was a good thing. That's the advantages of making it into wood. I'm going to put down this template on the description as a PDF file, and the article or the blog that Kyle the creator made. This is just printed on an A4 paper. Did not play with the ratios or anything of the file, the PDF file, just printed it out, as you can see. And for those that do not want to print this, or like do not have a printer, I'm just going to measure this out. I actually measured it out and recreated it to here. So this end is 7.2 centimeters. This end is also 7.2 centimeters, because of course it's a cube, and the gap between the LEDs, each LED is 2.4 centimeters. So by using these measurements, you can also make your own template and print it out on a piece of wood or a piece of cardboard or something similar. You can even use like metal, thin metal, if you have a metal drill bit, and you can drill through it with no issues. Although I don't really recommend metal, because working on wood or cardboard is a lot more easier than on metal, probably. So here's the template I just recreated. So as you can see, here we have 4 LEDs on this side and 4 LEDs on this side, and inside another 4 LEDs and 4 LEDs on each side. So that makes 16 LEDs on one layer. This represents one layer only. And on this template we need to make 4 layers. We just put 16 LEDs here, solder the plus connections together, and then make the negative connections stick out down to the bottom, and make 4 of these shapes, and then connect the negatives of those 4 of those layers, and reconnect their negatives to each other, and basically that way we have 4 layers and 16 columns. So as you can see, there is the measurements on here, and the measurements is 7.2 by 7.2 centimeters for the template, 2.4 centimeters LED gap for each LED, 16 LEDs for each layer, 16 by 4 is layers, and 16 columns. If you multiply it with the 16 columns, you have 64 LEDs in total right here. This is the positive LED layer connection, and these are the columns. And you can see the outputs on the negative outputs on the columns, like each column that would go down to this second or third layer, or fourth, depending on which layer you're working on. And on this template too, they just notified it too, like there's the negative part going out, and the positives are connected like this. But you might also ask, why is it an arrow on the negative part? Why isn't it just a symbol right here? Like if I show it on this template, like the LED here, this is the positive, let's assume, Actually, let me just try to draw it. Okay, this one would be the negative part, which would be the largest part of the LED, and this would be the thin positive part. So this is the positive right here, and this is the negative. Why wouldn't it be just a symbol like this on here, not an arrow like they did there? Let me just draw it again. I didn't draw it properly all that good, but anyway. So this is the negative. Why did it make it an arrow rather than a symbol, if you're asking? This is the reason why we're bending the negative pins of the LEDs on each column, because let me show you with an example of why we do that. So I have some LEDs right here. They're not white LEDs, but it doesn't matter for demonstrating this. As you can see, for example, this is an LED on layer 1. If we want to attach it to layer 2, the positive would be connected to other LEDs in the layer, so it would be like this. But if we want to connect it to another layer with the columns, as you can see, the LED would hit the top right here. The negative pin would hit the top of the other LED on the second layer or third layer or fourth layer, depending on which layer you're working on. So how do we solve this? We got a tweezer right here and hold it down on this little part. I don't know if I can show it on the camera. Yeah, as you can see, there is a little bit of a larger part right here on the LED. My fingernails actually getting caught on it when yeah, you see? There's like a little bit more metal on this part, and right below it we hold it with the tweezer and do a bending action like so. Right there. Just like so. So the LED would look like this, as you can see right here. And this way, if we put the LEDs on top of each other, on top of each layer, as you can see, we can easily connect the LED's other LED to the same column, and they wouldn't interfere. So that's why it's shown as an arrow. So if we put the LED on the template right here, as you can see, the LED's bending angle of the pin matches with the arrow. That's why they show it with an arrow. So with that out of the way, I also need to make another recommendation for your project, for this project. If you're using 5mm LEDs that doesn't have a little bit of a hue around it, and it's just a projector style LED, like it projects light to like what is in front of it. If you have an LED like that, and if you don't like sandpaper the sides of the LEDs, it would look awful when you finish the project. And this is why I painstakingly sandpapered 64 LEDs, like 64 of them, and all of them. And as you can see, they send light even to the sides. This is why it looks so great and looks more 3D like. I recommend you to do this. I strongly recommend you to do this, otherwise your cube would probably look pretty bad. You can use any color of LED, by the way. I just used white because I liked white on this project. You can also use other types of LEDs. Let me actually just bring more LEDs. Here is a red one like this with a diffuser right here. It doesn't just send light to in front, it also sends light to around what it's around. So if your LED isn't clear like this, you don't need to sandpaper it. And there is LEDs, white LEDs also, that are not clear and like have that foggy effect around them that makes it allow to send light to the sides too. But while I was making the project, unfortunately they were out of stock, so I needed to like painfully sandpaper all of them, all 64 of them. And I also made a simple solution to it. Let me show some other LEDs before I show that solution. As you can see, these are other color LEDs that are also clear. Some also green LEDs that aren't clear. Yellow LEDs, blue LEDs, other clear ones. And these are 3mm LEDs. The project we're using uses 5mm ones, so if you have 3mm LEDs, it probably won't work. But yeah, this is all the colors I have. I can show it to you for now. But there's a lot more colors that you can use, like different colors. You can even make each LED a different color. It would probably be a lot more expensive to do so, but it would also look pretty cool. But I just went with white, so that's what it is. And the easy solution I had for grinding down and like sandpapering 64 LEDs was using this thing, which is a mini drill. And it comes with different bits, a lot of bits, screwdriver bits, and it also comes with an extender. And you can hot glue sandpaper around this extender and make a Dremel bit. And this is exactly what I made. I just put it there, hot glued some sandpaper around this part. The sandpaper needs to be around 150 grits and below. If it's not that gritty, the LEDs are not gonna get like the LEDs are not gonna have the foggy effect all that quickly. So the grittier the sandpaper, it's gonna be better. And then I just press on the trigger and just wrap the LED around, like especially the sides, around the sandpaper while the machine's turning, like so. Let me actually demonstrate it on an LED. So here's the bent one I made right here. Just think that there is a sandpaper right here, even though there isn't. So I just pull the trigger and I just sandpaper the LED like this, all 64 of them, with the sandpaper. And it took like 3-4 hours, but it would have taken a lot longer, and I mean a lot longer, to like only make it with the sandpaper only, without wrapping it into like this and plug it in and putting it on a little drill to spin it. It really speeds up the process. I tried to sandpaper one LED on just side sandpaper, and it took like 5 minutes. But if I did the same thing on the drill, it would take like 2 to 3 minutes only. That's it. But it would like take 5 minutes, even more than 5 minutes sometimes, if the LED's outer coating is thick enough. So it would be like a lot longer without a drill, and I recommended using a drill like this to sandpaper your LEDs. Even though if your LEDs are not clear, like they have the foggy effect, to get even more, like even better view of the side wave of the LED, you can grind the LEDs that don't look clear too. It's just your preference, but with clear LEDs it would look pretty horrible, so please don't just use clear LEDs on this project. Use foggy ones at least. So this is how you grind the LEDs easily, and how you bend the LEDs so that they don't interfere with all the other layers, how you like print out the template, or how you can use these measurements to make your own template, how you can put the LEDs on top of the template and solder them together, how the construction is going to be. Now I'm just going to focus on the connections of the circuit and the project. So as you can see, here's the wiring diagram. The site that I pulled this project from makes this a lot more complicated than it needs to be, and a lot more confusing than it needs to be. If you're going to make this project by looking at the site, which is what I did. This is what you need to understand this stupid picture that doesn't make any sense. As you can see on this blog post by Kyle the Creator, this makes no sense to me. Like, what is that? 1, 2, 3, 4. 1, 2, 3, 4. What? I don't understand anything. Which column goes to where? What is the connection on the columns that are in between those edges? Like, it does not make any sense. It makes a little bit more sense when you read this text, but you need to like read it thoroughly, and even if you do so, it doesn't make all that much sense still. Like it says x1 1 column y is equals 4. What does this equals 4 part mean on the graph? What graph? Like, it doesn't make any sense. It would have made some sense if, like, they put like ones on these, but yeah, it still doesn't make any sense. So I made this diagram here that would make much more sense, to be honest. And so this is how the wiring is supposed to be. They could have just used digital pins of on the columns and just like named it like that, than using this nonsense, which is like a number table that like works with x and y and z coordinations. Like, it just doesn't make sense for most people. And this is how it works. This is the 1 LED, 2 1 LED. This is on the x-axis and this is on the y-axis. 1 LED, 2 1 LED, 3 1 LED, 4 1 LED, 1 2 LED, 2 2 LED, 3 2 LED, and 4 2 LED. 1 3 LED, 2 3 LED, 3 3 LED, 4 3 LED, 1 4 LED, 1 4 LED, 2 4 LED, 3 4 LED, 4 4 LED, and 1 1 LED, 1 2 LED, 1 3 LED, and lastly 1 4 LED. This X and Y coordinate naming system is basically referring to these pins that will be connected on the Arduino. So layer 1 goes to A0, layer 2 goes to A1, layer 3 goes to A2, layer 4 goes to A3. And these connections are individual columns that go to different pins on the Arduino. For example, 1 1 LED is going to pin 13, 1 2 is 12, 1 3 is 11, 1 4 is 10, 2 1 is 9, 2 2 is 8, 2 3 is 7, 2 4 is 6, 3 1 is 5, 3 2 is 4, 3 3 is digital pin 3, 3 4 is digital pin 2, 4 1 is digital pin 1, 4 2 is digital pin 0. These 1 and 0s are TX and RX pins on the Arduino, labeled as TX and RX. 4 3 is analog pin 5, and 4 4 is analog pin 4. So this is the So this is the wiring diagram, and if you understand the X and Y coordinates properly, and you have like basic geometry knowledge, you can probably understand it even just by looking at the blog post, but I did not, so I just made this diagram that would make much more sense. They could have just written the pins on each column and just called it a day, but they just ran through hoops to make it make more sense while making it make less sense, which is weird. Anyway, so this is how the connections are, and by using these templates that I printed out that will be in the description, and by the measurements that I gave you to make a template of yours, you can probably make something like this and then put LEDs on top, connect the positives on each LEDs, make 4 layers of them, and connect 4 layers with their columns together and make a cube. So the parts we need in total were a power source, an Arduino Uno or Nano, 64 LEDs, wires, perf board if you're going to make it a little bit more proper, and if you don't have a 3D printer to make a box for this project. I just used a cardboard box, like some cardboard, to make a box. So I just had to put the LED cube on top of the perf board, and making it on top of the perf board also makes it a lot simpler to wire it up, because the LED column leads are just going directly down to the solder connections on the back, which you can easily solder wires to, which is exactly what I did. And the layers will be connected with thin, very thin wires, like so, on this side and on this side and on this side. And they would look like this, like they would look like the color of solder, kind of grayish color, which kind of matches with the LED's leads and pins and just blends in like so. This is, for example, layer 4's cable, layer 4's positive connection. This is layer 3's positive connection. I didn't have any other I didn't have any other thin, very thin wires in my hands, so I just had to use this thick aluminum one, but it also worked, and no problem with only using that. So, and then this is like the layer 2 connection, and then this is like the layer 2 connection right here, going down to the perf board again, and this is the first layer's connection right there, going right into the perf board. And on the layer connections we need to use resistors. Why did I switch to British accent? Anyway, and on these layers we need to use resistors to protect the LEDs, of course, because the Arduino's output pins only output 5 volts. Sure, you can control the voltage on PWM pins, but not all pins of the Arduino are PWM pins, so you can't control each brightness of like each column on the Arduino. So that's the reason why we're going to use LEDs, because the Arduino outputs 5 volts. And the resistors that we're going to be using will be 100 ohms for these white LEDs, which need higher voltage than any LED out there with other colors. That's the reason why we use 100 ohms than like lower ohmage, more like 50 ohms, 30 ohms to make the LEDs brighter, is we need to minimize the current going through the Arduino, because the current would be quite high going through the Arduino if we used like 50 ohm or 30 ohm resistors instead of 100 ohms, which would limit the current down to only 200 milliamps on all columns and pins, which 200 milliamps in total separated across all 20 pins would make, I think, 10 milliamps on each pin, and the chip is going to output 10 milliamps on each pin, so it wouldn't need any cooling, or it wouldn't degrade the chip, which is why we use higher ohmage resistors. And if you have LEDs that draw that need even less voltage than 3 volts, which is what white LEDs require, you need to use higher resistors from like 220 ohms, 330 ohms, even 500 ohms if you use red LEDs. And you can also control the brightness by changing it to other like resistors. If you want it dim, like a dim nice night light, you can use 220 ohm instead of 100 ohm while using white LEDs, or you can make it really dim by using 330 ohms. And you can just combine resistors how you want. So we also, as I said, need to use 4 resistors. If we wanted to make this cube a lot more powerful and a lot more brighter, which we don't really need to do, this is powerful and bright enough in my opinion, we can use transistors on each layer, 4 transistors to be exact. You can probably use like a basic transistor that outputs around 100 to 200 milliamp hours, 100 to 200 milliamps, which is what each layer is going to consume at most, and 200 milliamp power draw is peak power draw, by the way. So if I turn it on, as you can see, it blinks, and when it blinks and all the LEDs light up, that's the highest current draw it reaches, which is around 200 milliamps. So the peak current is 200 milliamps, and if you use a transistor that could not deliver 200 milliamps, more like 150 milliamps or 100 milliamps, it would be fine, because all the LEDs only light up for up to 1 second, 2 seconds at most, which would be totally fine on the transistor and the Arduino. It wouldn't be an issue. So you can also use, as I said, transistors on the LEDs to drive each layer, in each individual layer. That way you'll be able to control the brightness of each LED, each 64 LED. And the reason how you can do that with transistors, but just by using 4 transistors instead of 20, is, as I said, the LED's plus connections are completely wired to the plus connections of the layers, positive layer LED layer connection, as I wrote down on this diagram or this template. So if you use if you want to use 30 ohm resistors, which would drive the LEDs from 30 milliamps to 40 milliamps on 5 volts, you can do that with transistors. Otherwise, if you use 30 or 50 ohms directly on the Arduino, you will probably fry the Arduino. This is why we're using higher ohms than lower. If you go lower than 100 ohms, it will probably fry the chip of the Arduino. This is what I'm trying to say. So these are the components that you need to make this awesome project, and I detailed everything about this, detailed it a lot, went into a lot of details, and this is basically how you make a 4x4x4 LED cube with Arduino. Thank you for watching. If you found this video useful, especially if you went on this video just for the wiring diagram and the explanation of the XY coordinates, and you really liked the video because of that, you can leave a like and consider subscribing to my channel. And if you share my channel with your friends that are interested in electronics, it would really help out my channel. Thank you for watching my video. I'm just going to leave you with the modes of this LED cube, and then the video will end and come to a close. So while you're watching this, thank you for watching, as I said again, and see you on the next video and next project.